This is a introduction into some of the topics that you're going to need to know for chapter 23, the last chapter of this semester. Uh, you don't want to dilly-dally. You want to get started on this as soon as is possible. So for chapter 23, it's about organic chemistry. So you're going to want to know the definition of organic chemistry so that you know what you're working with here. Another thing you want to know is why carbon? Why is carbon the study of carbon chemistry, organic chemistry, and the reason for so many organic compounds. Organic compounds are simply molecules. You also want to know how to draw organic compounds. You want to know a line drawing, the Lewis structure, the structural, condensed, and the molecular formula. The molecular formula is not a drawing, that's why it's not here in the parentheses. You want to be able to identify functional groups in drawings and from names. And you want to know what types of isomers there are. And you want to be able to identify the types of isomers from drawings. You also want to be able to name and draw constitutional isomers of alkanes. That's one of the functional groups. You want to be able to match constitutional isomers, name to the drawing to the name. And finally, you want to know reactions of alkanes, alkenes, hydrolysis, and polymerization. So just for a little more in depth, here, when we talk about the reason for so many organic compounds, it's basically because they're made out of living organisms. 20 million living or different species of organisms are going to make a lot of different compounds. And those compounds are made out of carbon. So why carbon? Why is carbon so interesting and the chemistry of carbon so interesting? Well, watch the videos and you'll find out. Okay. You also want to be able to decipher line drawings. For instance, this looks like a hill, but it is actually a line drawing. That means this right here. Oh, and it is missing a hydrogen. So these two lines mean 3 carbons plus these additional 8 hydrogens. This is called a condensed drawing. Now, this is a Lewis drawing and a structural formula. These differ only by lone pairs. If you have lone pairs, you would see them in a Lewis structure, but you don't see them in a structural formula. And of course, the molecular formula for this is C3H8. So you want to be able to go back and forth between these. This one is kind of left for you to kind of play with. You want to be able to identify functional groups in any type of drawing that we may draw. You want to be able to also identify functional groups from the name of the compound. Here are some examples. If you look at the word ethanol, which is the name of an organic compound, it is an alcohol. Ethanone, which is a type of organic compound, is a ketone. Ethanal is a type of aldehyde, and ethene is a type of alkene. These are just some examples of being able to identify the functional group from the name. And then we want to distinguish between types of isomers. We basically have constitutional isomers and geometric isomers. Optical isomers are one type of geometric, and cis and trans are another type of geometric. And these are examples of optical isomers, and these are examples of cis and trans. Constitutional, these are examples. So here's another couple of examples of constitutional isomers. These 2 are constitutional isomers. These 3 are constitutional isomers, which in this case are C3H8, and in this case are, C4H10 and C5H12. So constitutional isomers, constitutional isomers. You want to understand alkane reactions, and we basically have 2 alkane reactions. We have something called halogenation. It sounds like you're putting a halogen on an alkane. You're right. And we also have combustion. Combustion is a special type of redox. You also want to know alkene reactions, and this is basically your setup of an alkene reaction. You take an alkene, which has a double bond, and you add AB to it. Notice in this case, you add A to one side, B to the other, but it could go the other way. When you have H2, A is H and B is H. When you have HCl, you can let A be H and Cl be B, and so forth and so on. If you had H2O, you could let A equal H and B equal OH. And of course, there's one more combustion of alkenes, and that is if you react them with oxygen, you get CO2 and H2O. As far as the reactions go for hydrolysis, we'll be learning about those as we go along in the course. So this is just a brief introduction to your organic chemistry chapter. Please do not wait to start this chapter.